Welcome to the deep dive. If you are prepping to build your own decentralized applications, or maybe if you're just intensely curious about the actual architectural shifts happening in digital finance, you're in a perfect place today.
You really are.
Yeah, because we are breaking down a really illuminating module from the Vibe Code blockchain course.
Yeah.
Specifically, we're diving into Module 4, which is essentially, well, it's a masterclass on protocol-level finance.
Exactly. You are looking at a fundamental evolution in how networks handle value. By the time developers reach this point in the Vibe Code curriculum, they've already moved past the basics.
Right, they know the basics.
Yeah, they've spun up their environments, they understand basic ledger state, and they've, issued custom tokens. Now they are stepping into the engine room. We are looking at a system where complex financial primitives aren't just tacked on as an afterthought, they are baked directly into the base layer of the network.
Right, baked right in. And the mission for our deep dive today is to completely demystify exactly how that engine room works on the Stellar network. We're going to explore the Stellar Decentralized Exchange, or the DX, which operates entirely differently from what you might be used to. We'll break down the mechanics of cross-border path payments, explore how to build an automated trading bot, and look at the shift toward native automated liquidity pools. The goal here is to show you the literal blueprint for bypassing traditional financial friction. Keep it totally beginner-friendly, of course.
It is a profound shift, really. We spend so much time in the crypto space talking about DeFi as this layered, often precarious ecosystem built on top of blockchains. But what we're analyzing today is an architecture that treats exchange and liquidity as fundamental rights of the ledger itself.
Okay, let's unpack this, because the very first major takeaway is a massive plot twist, if you were coming from the Ethereum ecosystem.
Oh yeah,
When most developers think of a DX, they think of Uniswap or SushiSwap. They think of these massive, complex smart contracts. But the Stellar DX doesn't use smart contracts at all.
What's fascinating here is the deliberate architectural choice and the trade-offs it represents. Think about the current paradigm on networks that rely on Turing-complete smart contracts.
Okay.
Every single time a user wants to trade or a developer wants to deploy a new liquidity pair, they are interacting with external code compiled on top of the blockchain.
Which means gas fees.
Exactly.
Yeah.
You are paying computational gas fees just to execute the contract logic. But more importantly, you are taking on massive smart contract risk. You are trusting that the developer who wrote that specific pool didn't leave a backdoor
Or make a routing error.
right, or leave it vulnerable to a flash loan attack. Because the Stellar DX is built directly into the protocol as a set of native operations, that specific friction totally vanishes.
But wait, let me play devil's advocate for a second. By stripping out smart contracts, aren't we losing flexibility? What if I want to build some, I don't know, highly complex bespoke derivatives platform? Doesn't a native hard-coded protocol restrict me?
It's a great question.
Yeah.
And yes, it does restrict you if your goal is to build highly experimental, custom financial derivatives on the base layer.
Right.
But that's the trade-off. Stellar's design philosophy prioritizes security, speed, and standardization for the transfer of value. By moving the exchange logic into the core protocol, there is no contract deployment. There are no variable gas fees that spike when the network gets busy.
That's huge.
The trading logic is just a fundamental, unchangeable rule of the network, much like sending a basic payment.
And the mechanics of how it operates are surprisingly straightforward once you wrap your head around it. The DAX is fundamentally order book based. You are placing limit orders to trade any two assets on the network. If you spin up a brand new custom token right now, you can instantly trade it against anything else, say the native XLM token or a digitized fiat currency. There are no permission gates.
Right, and it's a completely passive matching system. When you submit an offer to the network, one of two things happens. If there's a matching offer already waiting on the other side of the book, your trade fills immediately.
Boom, done.
Exactly. If there isn't a match, your offer simply rests in the order book. It sits there, natively stored on the ledger, until a match comes along or you cancel it.
And we have to talk about the speed, because this isn't a smart contract executing. The matching happens as part of the core consensus. Trades on the Stellar DX settle in the exact same 3 to 5 second window as a standard transaction.
Just pause and imagine what that kind of speed means for someone building a financial application.
It's wild.
You aren't forcing your users to wait minutes for block confirmations. You aren't worrying that the market price is going to swing wildly while your transaction is stuck in a mempool. In 3 to 5 seconds, the ledger closes, the trade executes, and it is cryptographically final.
That is incredibly fast. So how does a developer actually interact with this? Instead of deploying code, you use native operations. The two fundamental building blocks here are operations called manage sell offer and manage buy offer.
Yep.
Let's say you're building an app and you want to sell a custom token you minted. You simply fire off a manage sell offer operation.
And you just provide the network with the specific parameters. You declare the asset you are selling, the asset you want to buy, and the total amount you're offering.
But the way you set the price is what I found really elegant. Instead of dealing with complex floating point decimals, which can cause massive rounding errors in financial software.
Which is a nightmare.
Absolute nightmare.
Yep.
You express the price as a ratio, a simple numerator and denominator. So if you want to sell at a price of 2.5, your ratio is just 5/2.
That precision is critical when you are dealing with global currencies. And there's another beautifully simple mechanic here regarding how you manage these orders. Let's say market conditions change, and you need to cancel that offer. You don't need to call a separate kill function or deploy a cancellation contract.
You just submit that exact same manage sell offer operation. You pass it the unique ID of the existing offer you want to cancel, and you set the amount to 0.
Simple as that.
That's it. Amount equals 0, and the network immediately wipes it from the order book on the next ledger close.
It's a very clean system. And once you understand those basic atomic units placing offers, checking the state of the order book, and canceling offers, you have everything you need to build automated trading systems. This is where the Vibe Code module gets incredibly hands-on.
Yeah, the vibe coding prompts.
It walks developers through building their own Node.ace trading bot.
Yeah, those prompts are brilliant because they take this abstract protocol concept and turn it into executable code.
Right.
The specific architecture they outline is for a bot that acts as a simple market maker.
Let's demystify that term for a moment. In traditional finance, market making was a function strictly reserved for massive institutional banks with rooms full of servers.
Right, the big players.
Yeah. A market maker provides liquidity to an exchange by being willing to buy and sell an asset at all times. They ensure that when a regular user shows up to trade, there's always an order waiting for them.
And the bot outlined in the module democratizes that exact function. It's a simple script. First, the bot queries the network to fetch the current mid-price for a specific trading pair on the DEX. Then it places a buy offer 1% below that mid-price and a sell offer 1% above it.
That 2% gap between the buy and the sell order is the spread. If an impatient trader comes along and wants to sell their tokens instantly, they will hit your bot's buy order.
Yep.
If someone else wants to buy instantly, they hit the sell order. Every time both sides of that trade fill, the bot captures that 2% spread as profit.
And to keep the strategy running, the script just uses a basic interval loop. Every 30 seconds, it wakes up, checks the new market mid-price, and replaces any offers that were filled. It's fully automated.
But, and this is a massive but for anyone listening who is thinking about firing up a code editor right now, the module lays out some critical safety rails. Financial automation is powerful, but it's completely unforgiving.
Totally. The very first rule, always verify. You are pointing your bot at the Horizon testnet API.
Oh, absolutely.
The testnet functions identically to the mainnet, but with fake assets. You never want to accidentally point a brand new, unpolished script at the public network with real capital on the line.
And beyond that, your code needs to be resilient. The module stresses that your bot has to handle API errors gracefully. If there's a minor network timeout or a rate limit is hit, your script shouldn't just crash and leave your funds exposed. Furthermore, you must ensure that old open offers are successfully canceled before placing new ones around a shifting mid-price. Oh, right. Because if the market price is moving and your bot is just blindly placing new orders every 30 seconds without cleaning up the old ones,
your stale orders will just stack up indefinitely. You'll end up with a massive trail of terrible positions tying up all your capital, and eventually the market will swing back and execute all of those bad trades.
ouch. Yeah, air handling's not optional.
No, it really isn't.
Here's where it's really interesting, though. We've talked about trading and we've talked about bots capturing spreads, but the module pivots to a feature that leverages this entire order book infrastructure for something much bigger. They call it Stellar's cross-currency superpower, and it's known as a path payment.
If you were trying to understand the actual utility of blockchain technology beyond speculation, this is the concept to master. A path payment allows you to send one type of asset, and the person on the receiving end gets a completely different type of asset.
And it's atomic. The network automatically routes the value through the intermediate order books on the DX to perform the conversion in real time. To really grasp why this is a superpower, you have to look at the friction in the legacy system. Let's look at the real-world application the module uses, which is sending money from South Africa to Nigeria.
If you do that through traditional banking, it is a nightmare of inefficiency. The money might have to leave a local bank in South Africa, route through a correspondent bank in Europe, get converted into U.S. dollars,
Right.
route to another correspondent bank, and finally land in Nigeria where it's converted again into Naira. It takes days, and every single middleman takes a cut of the exchange rate.
Exactly. Now, contrast that with a Stellar Path payment. The sender initiates the transaction using digitized South African Rand or ZIR tokens. The receiver is set up to accept Nigerian Naira, NGN tokens.
Okay.
The protocol looks at the DIA text, finds the best available exchange rates between ZIR, perhaps routing through XLM as a bridge asset, and then into NGN. The sender never holds the Naira, the receiver never holds the Rand.
Stellar chains the order books together, executes the conversions, and delivers the final asset to the receiver's wallet, all in that same 3 to 5 second consensus window.
It effectively makes the concept of a currency boundary invisible to the end user.
The module goes even deeper into this with a really detailed remittance architecture. Imagine a cross-border payment app for migrant workers sending money from the UK to South Africa. The user experience is seamless, but under the hood, the app is utilizing these native operations.
Let's trace that flow because it highlights the role of anchors. A worker in the UK deposits physical British pounds with a local UK anchor institution. That anchor mints digital GBP tokens and credits them to the worker's Stellar wallet.
Then, the app fires off a TAF payment. It sends the GBP tokens into the DCUX.
Yeah.
The order book converts the GBP into XLM and then instantly trades that XLM for ZIR tokens.
Yep.
The app can even set a slippage tolerance, say 2%, so if the market suddenly crashes during that 5-second window, the transaction safely fails rather than executing at a terrible rate.
And on the other end, the recipient gets the ZIR tokens, which a local South African anchor instantly honors by depositing real, physical rands into their local bank account.
It's beautiful plumbing.
Yeah.
But as a developer building that app, you have to choose exactly how you want that path payment to behave. The module details 2 distinct NATO operations for this, and the difference between them is absolutely crucial. You have path payment strict send and path payment strict receive.
If we connect this to the bigger picture of user experience, these two operations solve very different problems. Let's start with strict send. You use this when the sender has a fixed budget.
Okay.
Suppose you want to send exactly 100 GBP to your family, and whatever that converts to in the other end is fine. You are strictly sending a fixed amount. The network takes your 100 GBP, pushes it through the best available path on the DX, and the receiver gets a slightly variable amount depending on the exact exchange rate at that millisecond.
But what if you are paying an invoice? Let's say a freelancer in South Africa bills you for exactly 10,000 ZAR. You can't just send 100 GBP and hope the exchange rate works out to 10,000 ZAR. If it falls short, you haven't paid your bill.
Exactly. That is where path payment strict receive comes in. The name says it all. It strictly enforces the received amount. You tell the network, the destination account must receive exactly 10,000 ZAR. I am paying with GBP.
So the protocol calculates the path backwards.
Yes. It looks at the DS liquidity and calculates exactly how much GBP you need to spend to guarantee that 10,000 ZAR output. The amount you spend might fluctuate slightly depending on the market, but the received amount is mathematically guaranteed.
Okay, but if the market is constantly fluctuating, how do you show the user a reliable exchange rate before they hit the send button? You can't just guess.
You don't have to guess. This is where the Horizon API becomes your best friend as a developer. The module explains how to query the /paths endpoint. Before you ever construct the transaction, your app sends a request to Horizon with your source asset, your destination asset, and the amount.
And Horizon returns the exact conversion paths currently resting on the order books.
Precisely. It allows your app to instantly display the effective exchange rate, the intermediate bridge assets being used, and the estimated final arrival time and amount. It gives the user complete transparency before they commit to the trade.
In fact, the vibe coding exercise in this section has developers building a receipt generation function. You pull that path data, and you display the total amount sent, the amount received, and the exact fees. It's giving institutional-grade transparency to an everyday user.
It's a very robust system. But it's worth noting that relying purely on order books where users and bots have to actively place limit orders requires a lot of constant market participation to ensure there's enough liquidity for these path payments to function smoothly.
Which perfectly sets up the massive plot twist the module introduces toward the end. In 2021, the Stellar protocol underwent a major upgrade. They didn't just stick to the traditional order book. They introduced automated market maker, or AMM, liquidity pools directly into the base layer.
This was a brilliant evolution. We just spent a good chunk of time discussing how a developer could write a Node.js bot to act as a market maker, constantly placing buy and sell orders, managing spreads, and handling server errors.
Which is incredibly cool, but also a lot of work.
It is active management. AM liquidity pools provide an alternative that requires zero active management. It brings the passive liquidity model popularized by platforms like Uniswap, but again, without the smart contract risk or the gas fees.
So how does a developer or a user actually interact with this natively? Let's say I have a stack of XLM and a stack of that custom token we talked about earlier. Instead of firing up a trading bot, I just use a single operation called liquidity pool deposit.
That's it. You bundle a pair of assets together and deposit them directly into the protocol's liquidity pool. Once your assets are locked in that pool, you don't have to do anything else. The protocol's algorithm automatically quotes prices to anyone on the network who wants to trade between those two assets, adjusting the price based on the ratio of the tokens left in the pool.
And anyone doing a path payment might automatically get routed through your liquidity pool if it offers a better rate than the traditional order book. The protocol is smart enough to check both and pick the most efficient route.
And here's the incentive structure that makes the whole AMM system thrive. By depositing your assets and providing that liquidity, the protocol automatically collects a 0.3% fee on every single trade that routes through your pool.
It's passive income. You aren't adjusting limit orders. You aren't paying server costs to run a node script. The base layer is algorithmically handling the pricing and collecting those fees on your behalf.
And when you are ready to exit your position and take your capital back, it's just as simple. You submit a liquidity pool withdrawal operation, you provide your pool ID and the amount of pool shares you want to redeem, and the network immediately returns your underlying assets, plus your share of the accumulated 0.3% trading fees.
So what does this all mean? When you zoom out and look at this module holistically, it provides a comprehensive blueprint for modern financial architecture. You have a built-in decentralized exchange that settles in under 5 seconds, completely immune to the risks of faulty smart contracts. You have the exact API parameters to code your own automated market-making bots. You have path payments that can seamlessly and atomically bridge global currencies in a single transaction. And you have native AMM liquidity pools for passive decentralized fee generation.
It completely reframes how we should think about financial infrastructure. We aren't just talking about speculative crypto trading here. We are talking about real utility.
Exactly. Whether you are actively designing the next major remittance application or you're just trying to understand the underlying mechanics of how digital value moves, this module proves that the tools are more accessible and more powerful than most people realize. You don't need to reinvent the wheel. The protocol already handles the heaviest lifting.
This raises an important question, though. We've talked extensively about how anchors act as the bridges between legacy fiat systems and this high-speed digital ledger. We've seen how straightforward it is to code a system that instantly routes GBP to ZAR AR through an immutable 5-second path payment with a guaranteed exchange rate.
The technical barrier to entry is just vanishing.
Right. So if any developer with a basic understanding of Node.js and an internet connection can utilize this native protocol to build a remittance tool that bypasses correspondent banks, eliminates days of settlement delays, and severely undercuts traditional exchange fees, what happens to the legacy foreign exchange brokers? What happens to the massive institutions that have held a monopoly on cross-border payments for decades when this technology simply becomes the invisible, ubiquitous plumbing for every financial app on our phones?
That is a phenomenal and perhaps slightly terrifying thought to leave on if you're a legacy banker. The infrastructure is built, it's running, and it is waiting to be utilized. Thank you so much for joining us on this deep dive into the architecture of decentralized exchange. We hope it sparked some serious ideas for you and gave you a clearer picture of where the tech is actually heading. Keep building, keep questioning the systems around you, and we will catch you on the next deep dive.